Test sieve analysis would be nothing without ISO standards, so I think it's about time that we talk about them. And specifically for this video, the ISO 3310-1-2001 standard and how it affects sieve construction. Stick around. Hey there, what's up? My name's Andrew Kotlar, and to provide reliable results, your test sieves must be highly accurate. That's why standards like the ISO 3310-1-2001 standard have been put in place. They establish tolerances to create and set the bar for accuracy. So what test sieve tolerance does it establish? W.S. Tyler has been a trusted voice in the particle size analysis industry for over 150 years. We take pride in fabricating precise sieves that comply with ASTM E11 and the ISO 3310 standards. So in this video, we'll go over the definition of sieve cloth, why test sieve tolerances must be put in place, the tolerances set by the ISO 3310 standard, and how test sieve quality is managed. Sieve cloth is a laboratory-grade woven wire mesh fabricated under ASTM E11 and ISO 3310-1-2001 guidelines. These standards work together to dictate the nominal aperture size and wire diameter that ensures accuracy. Now, sieve cloth is typically used to fabricate test sieves, but there are cases where it can be used to screen dry, free-flowing material on a large scale. Sieve cloth mesh is woven using identical techniques as industrial textile weaves. This means that blemishes that happen during the weaving process can ultimately affect the reliability of your test sieve analysis results. For instance, if a particular aperture or pore opening is smaller than intended, then odds are one of the apertures in the proximity is larger than intended. Because of this, tolerances have been put in place to standardize a specific level of statistical precision. The ISO 3310-1-2001 lays out guidelines about the number of apertures that must be measured as well as what position of the sieve cloth is in. With that, the following aperture size tolerances are tested when using woven wire mesh sieve cloth. The +X tolerance states that apertures in either the warp or weft directions are expected to be within a W+X tolerance. If the apertures exceed this tolerance band, then the test sieve is rejected. The ±Y tolerance requires the mean value of the apertures measured to be calculated. The mean value of the apertures in the proximity, however, is not. Instead, the mean value of a wide range of apertures spanning the diameter of the test sieve, both vertically and horizontally, is calculated. The standard deviation is based on the measure results in their entirety. It is put in place to highlight the total number of apertures that must be measured to generate results that are statistically backed by data. The quality assurance measures reflected in the 3310 standard is closely based on those reflected in the ISO 9044 standard. This means that test sieves manufactured under 3310 must be calibrated. And inspection laboratories must use calibrated test sieves that fall within a threshold of 99.73% of the standard deviation multiplied by 3. Thanks so much for watching. If you have any questions, fill out a contact us form so we can answer your specific questions. Just click the link in the description. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. Just click that second link and you'll be that expert in no time. And don't forget to click the subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name's Andrew Kotlar, and I'll see you around in the next video. Bye for now.